All right, 4-2. Graphing polynomial functions. Yes. We have 3 examples, and then we're done. Graphing polynomial functions. So first of all, go back to your understanding of what a polynomial is. Polynomial is when it's those nice, pretty integer numbers. So x squared minus 1, 4x cubed plus 2x squared minus x plus 4. That's a polynomial. The idea is we're going to graph our polynomials, but we're not going to use our graphing calculator. Now you'll use it for finding extra points, but we're not going to y equals at all. So you need to wrap your mind around 2 things. And this is why in the last section, 4.1, I was able to tell you if there was more answers that we had not found yet. If you have any type of polynomial and its degree n, which means whatever the degree is, then that means that there's at most that same number of real zeros, which means x-intercepts. And then in terms of the graph, remember we said polynomials are nice smooth curves, whether it's a quadratic or Saturday Night Fever or to the 4th degree, which kind of has little extra curves in it. There's an association between knowing the degree of a polynomial and being able to say, okay, well then this is how many possible solutions there are. And if I'm talking about solutions, that means I'm also talking about x-intercepts. And you can also say about how many turning points there are. So what does this mean in a nutshell? If it has degree n, right, then there is at most, meaning it can't be more than, at most n zeros. And remember, the word zeros is another word for x-intercepts. It also means that there is n minus 1 curves in the graph. Those curves are actually called turning points. So remember 4.1 where we used the leading term to say whether it was even or odd in behavior, right, based on the degree, to say whether it was a like a parabola-like curve, or if it was Saturday Night Fever, or if it was the leading term was negative, if it's reflecting over the x-axis, opening down. All of that came from the leading term. Remember the example that I threw the 4 graphs on the board and you, by multiple choice and looking at just the leading term, figured out which graph goes to which function without graphing it, right? That was in 4.1. Okay, so now I'm telling you another thing based on just the leading term, and it comes from the degree. If you have, say, a degree 4 polynomial, then that means there's at most 4 real solutions. There could be 4, 3, 2, or 1, or none. Could be imaginary. But it means there can't be 5. Can't be 6, because it was a degree 4. If it's a degree 6 polynomial, it could have 6 answers, 5 answers, 4 answers, 3 answers, 2 answers. You see where this is going? Can't have 7 though. So the degree dictates how many possible answers you're going to come to, and it's never more than the degree. Now, you could have a degree 2 polynomial, which is a quadratic, and if it's sitting on, you don't need to draw this, but if it's sitting on the x-axis, then that means it's only crossing the x-axis 1 time. But you might think, well, it was a degree 2. Where's the second answer? This is saying, I'm not telling you exactly how many there are every time. I'm telling you there is a relationship between whatever the degree is sets the tone for how many possible answers there are. Okay? The curves means literally what it sounds like. When you go to graph it, you will curve one less than the degree number of times. For instance, what's the degree of a quadratic? 2. Everybody knows what a quadratic looks like. How many curves are in a quadratic? 1, because 2 minus 1 is 1. What's the degree of Saturday Night Fever? Y'all should know this. What's the degree of Saturday Night Fever? 3. Okay, so you got the Saturday Night Fever has 1, 2 curves because it's a degree 3. You see the relationship? So this is huge. This is saying, okay, from now on, if I tell you, here's a polynomial, and I say, find the zeros, and let's say it was a degree 4, and you wrote 5 answers, you should know something's wrong, right? Can't be more than that. No, don't give that to him since he's already loaded up with the other medicine. Okay, go to this slide. Now we're going to actually put it all together. Okay, don't write big. I don't know if y'all can see mine. Don't write big. I'm just saying, don't write big because we got a lot to write. We are going to graph this polynomial as best as we can without using y equals on our graphing calculator. And it's going to make you feel like a genius because this is what I love about this stuff. Because I can look at this and I can sketch a graph without my calculator and it blows people's mind, which I always enjoy. First of all, go back to what we've already practiced. The first thing you need to do is ask yourself, what's the leading term? What is the leading term in that polynomial? Negative 2x to the 4th, right? I'm just going to copy it here. Okay, so because it's to the 4th power, you need to tell yourself that's an even number, which means, come back to like the quadratic, because that's an even degree. It's going to be both ends up or both ends down. How do you know which way it is? You look right there at the sign of that leading coefficient. It's negative, so it's going to be both ends down. So you're just going to kind of sketch to yourself, okay, so it's going down. The next part is the algebra behind it, where we actually need to find the zeros. You need to get used to the word zeros, but it's basically saying solve it. When y is 0, okay? Now, here's where you got to get comfortable with polynomials and factoring, okay? You've got to know when is it an a times c, draw the x, fraction shortcut factoring method. When is it the 4 terms, factor by grouping method? When is it a GCF method? Look at this. How many terms are there total? There's only 2. And it's to the 4th power. Okay, so do you notice they have anything in common? They have x to the 3rd in common. So if we can pull a GCF out, then we would have the GCF times some crap equals 0, and we could go straight to 0. So you should appreciate when it's the factor by GCF method, which is short, sweet, straight to 0. Let me show you what I mean. I'm finding the zeros, which means I'm solving it. That means the y is 0. X to the 4th plus 3x cubed. I notice there's 2 terms, and I notice the 2 terms have a common factor. I'm going to pull the factor to the front. So divide it to the front. I think I divided negative x cubed so that that 2 would become positive. It does not matter. The negative doesn't play a role right there. but I'm going to divide negative x cubed out. Because now in my parentheses I'd have a positive 2. It would look normal instead of a weird negative 2 leading in the parentheses. You can do whatever you want there. I'll show you both ways in a second. Alright, so if I divide a negative out of this, x cubed, ask yourself, if you struggle with going in the direction of dividing polynomials, then rephrase the question. What does this need to multiply by to give me that? Because a lot of people tend to be able to do that really quick. Negative x cubed times what would give me negative 2x to the 4th? 2x. See? So we're going to write 2x. Repeat. Negative x cubed times what would give me 3, positive 3x cubed? Negative 3. Now, had you not pulled the negative out, it would look like this. And you'll still come to the same answer, but this just drives me nuts right here, so that's why I pulled the negative out. But you would still come to the same answers. Okay, so now, if you need to make a note, this is the factoring by GCF method. When there's just 2 terms, you see a GCF, you pull it to the front, because now you've got some crap times some other crap equals 0, so we're ready to set each of them equal to 0 and solve. So, negative x cubed has to equal 0, 2x minus 3 has to equal 0. This looks and probably feels weird. Divide by negative. Don't overthink this. Divide by negative. It'd go away. Right? Does everybody agree? 0 has no sign. 0 divided by negative 1 is 0. How do I undo something that's cubed? You cube root it. And you might think, oh dear Lord, where is she going with this? It's just 0 though. Right? You're just cube rooting 0. What's the cube root of 0? 0. Now, because it was a cube, that's the equivalent of x times x times x. So what type of multiplicity do we have here? We've got a multiplicity of 3. I think that's cookies.
Wow. Joining us today.
Huh?
Hey, I charged your calculator
Thank you.
for you, and I'm pretty sure it's charged all the way now. Double check. Yep. And go grab a fork. Oh, don't sit. Never mind, I'll get it for you. I'll get it for you.
Is it over there?
Yeah, it's on the top shelf of the tray, and I didn't write names on them. Oh, Riley doesn't feel good.
Okay.
They did. They have some.
Who just walked out? Who just walked out?
Me?
Already?
He was just awake.
Oh, you're just resting.
I mean, we're not doing anything.
Do you sleep in all your other classes? Yes, yeah, sleep in the whole time. Well, I sleep in Charles too.
No, I don't.
No?
You don't sleep in that one?
Shelf
What's so special about him?
I'm not tired.
I used to sleep in Shelf all the time.
I'm just not a morning person. Even no matter how much sleep I get, I just stay there.
I am the same way, and my husband is, and it is a disaster. He'll be, you know, and I'm over here just like this face of. One time I looked at him and I said, "You know how I am in the mornings, and yet you're still running around." Do you understand where the multiplicity of 3 comes from?
What does that mean?
Well, I'm going to show you when I get to the graph. It matters. So this one I'm going to solve. Divide by 2. Did you have any good notes on that? You get 3 halves, which is 1 1/2. What type of multiplicity does that one have? Well, look back up at it in factored form. This is where you find your multiplicity answer. You look at it when it's in factored form, and it's the exponents. This had an exponent of 1, so this is with multiplicity 1. Now the next part to graphing it is, once you've just found your zeros, you're going to translate this to what's called your x-intercepts. So this part is the exact same answer as that step. It's just now we're going to write them as coordinate points. Okay? So we had right here, the 0 was the number 0, which is the coordinate point 0, 0, right? Now, how many times was it repeated? So I'm going to put right here just times 3 to tell me, okay, there was a multiplicity of 3 there. I'm not actually multiplying 3 into that. That's me saying, hey, it gets repeated 3 times. And then this 0, 1 1/2 translates to the x-intercept 1 1/2, comma 0. And how many times was that repeated? None. So I'm just going to say times 1. Yeah. Yeah. Are you choking?
No. Yeah, she is.
Because it's stuck. You have to get your throat stretched. Then we need to find the y-intercept. You may not remember this, but let me remind you, the y-intercept's the easiest one to find because think about it. And if you forget this, like when this test comes up or the homework comes up, you know where the y-axis is, right? Okay? And if it's a y-intercept, that means it's on the y-axis. What is the x value of every point on the y-axis? 0, which is telling you plug 0 in for x, and then you'll have your y-intercept. So if you need to make a note here of how to get the y-intercept, maybe make a little note, plug x equals 0 in. Always go back to the original though. Don't plug it into your factored form, because 1, what if you factored wrong? Or 2, in the original, when it's multiplied out, you don't even have to type it in your calculator, because 0 makes terms disappear. So that term would disappear, and that term would disappear, which means my y-intercept would end up being 0, 0. Which makes sense, because one of the x-intercepts was that point, and you can only have one y-intercept, or it wouldn't pass the vertical line test. There is always only one y-intercept. Now, there could be a chance where there's always one. Every time, because the domain's all real numbers, so at some point it's going to cross the y-axis, and it will only cross it in one spot because it's a function. That's the beauty of it. Okay, so now, we took the leading term, we have the end behavior, we found the zeros, which now we have them as coordinate points. Okay, so this tells me on this graph, I definitely have something here. I have a point at 1 1/2, 0, which is kind of hard to graph on here, but we're going to do the best we can. And then I've also got another 0, 0, like that it's repeated. The y-intercept is also on here, but I've already got it graphed. So it's all starting to come together. Now, the next part is where you just say to yourself, okay, now I need to know where the graph is around those points. I know what it's doing at the end, right? I know that it's going to go both down somehow. Like, I know it's going to go down. But I it's doing around here. Oh gosh. I don't know what it's doing around here. Okay, so just oh gosh. No, it's so funny. You try to avoid stuff like that, and then it just happens organically. And it's like, no one has really pointed it out. I wouldn't even have thought of it. You were like, oh gosh. So, what? Yeah, you just gotta pay attention. You never know what you're gonna miss. So this next part is called where you're trying to find extra points. Okay, this is where you want to think smarter, not harder. This is a polynomial, which means the domain's what again? All real numbers. Which means any number you pick and plug it in, you're going to get an answer, right? Okay, you also should know that with polynomials, they tend to, once they go off in a certain direction, like that's it. All the activity is around where the curves are, right? Okay, so do I really want, if this is where I'm going to have some curves, I'm not even about to sketch it again. If this is where I'm going to have the curves to the polynomial, then do I really want to plug 10 in? No, because 10's nowhere near it, right? Do I want to plug like negative 12 in? I want to plug numbers that are like right around in here, because then I can actually see where the curve is. So this is where some people get confused because they don't know how to pick their points. And I'm telling you right now, you're going to pick your extra points around your x-intercepts because that's where all the activity is. Okay? So let me show you the way that I do this. I draw a number line. I draw a nice long number line. And I plot my x-intercepts on it. And of course, since my x-intercepts are 0 and 1.5 already close together, I spread it out. So I say to myself, okay, I definitely have something at 0. Then I have something at 1.5. Now this is where you've got to have spatial awareness with your numbers. Did y'all ever know that the x-axis on the coordinate plane is just the number line? Has anyone made that connection with you? That the x-axis on the coordinate plane is, when you look at it by itself, it's just the number line. So have some spatial awareness with your numbers. Like if this is 0, then clearly what type of numbers are left of it? Negatives. And then if this is 1.5, like what pretty number would be in between? 1. And then what immediately pretty number would be next? 2. Okay, so here's what I do. I draw marks to myself and I put a question mark. I say to myself, okay, I'm definitely going to check -1, and I put a question mark because I haven't checked it yet. And then I find another pretty number in between here. I'm going to check 1, and then I find the next pretty number, I'm going to check 2. You want to check a number in each section. If you look at your x-intercepts, how many sections did it just cut the number line into? 3. So you need a number from each section because you need to know where the curve is. Now here's where we can go to our calculator, but we're not using y equals because the idea is to be able to graph this without the y equals. So you would go to your calculator and now you are literally plugging these numbers in. So I'm going to, I'm not testing, but I'm going to find, this was called h of x. I'm going to find h of -1. I'm going to find h of 1, and I'm going to find h of 2. Those were the numbers I picked. And now you go to your calculator. Please, please, please put -1 in parentheses. sometimes that thing disappears. Sure, from my calculator. You should get -5, 1, and -8, right? So, typing the function, you got -2, parentheses, I'm checking -1 to the 4th power. Hit the caret button right here. It looks like a little rooftop. 4. Then you got to come out of the exponent's place. +3, -1 squared. Nope. This is the third. -1 caret 4 +3 caret 3. There you go. Once you type it one time, let me show you a shortcut. 2 things you can do. You can arrow up and then highlight it and just hit enter. Or you can hit second enter, and it'll repeat the last thing you entered, and then it'll allow you to go over it and change the number as you need to. Like I'm just going to delete the negative. And then you're not retyping the whole thing. And then second enter, I'm going to change it now to 2.
Yeah.
Did you get -5, 1, and -8? Alright, so you've just found 3 more points on your graph. I don't know if you remember this, but that is the point -1, -5. That is the point 1, 1. That is the point 2, -8. So plot them. And then that's it. Now we are going to sketch the graph. If you recall, 0, 0 had a multiplicity of what? 3. Which means when I go to 0, 0, you might want to make a note to yourself that I'm drawing an arrow to that 0, 0. This was times 3. What does it matter? Okay, think to yesterday. If it has an even multiplicity, it's exactly like the even behavior of a graph. It's going to come to the x-axis, bounce off of it, and go back in the other direction, in the direction it came from. If it has an odd multiplicity, it's going to come to the x-axis and then lay across it just a little and then cross over. Okay? So here's where you're putting it together. Remember, it does what at the end? It's going to go down. Find your outer points. So like my outermost point would be that one here, and then over here it'd be that one. So it's going down, right? And then now the next part is just a sketch, and you are connecting the dots in the order of the x values as they appear. Like don't come over here and connect. Don't do that. You are connecting it in the order of appearance as you read it like a book. So I've got to somehow come to this one. Now, this is where I have my odd multiplicity. So instead of just going straight through like that, because it's an odd multiplicity, it's going to come to it and kind of lay across it and then curve back up. And it looks really weird. That's a really tight little area right there that's kind of hard to focus on. And the good news is in MyMathLab, they are not going to ask you to sketch the graph because they don't have the means to grade that from you. Now, that's where my former classes They used to have to sketch this by hand. That was the way the test was. No calculator, they had to sketch it by hand. I'm looking to make sure. There's 9 questions on MyMathLab. Questions 1, 2, and 3 is saying, hey, here's the polynomial. Tell me how many zeros it can have, how many x-intercepts, how many curves. Number 4 is just like this. I don't know exactly, I don't have a note on here like based on the widget, so I'll pull number 4 up. But number 4 is just like this. And then the rest of the questions are being able to state how many possible answers there are and put it in factored form. So there's one graphing problem, okay? Does that make sense? Let's go to this one. I'll pull number 4 up so y'all can see the widget. All right, let me show you, like, question 4. It says, graph this polynomial function, and then it says, here, use the graphing tool. What type of mother function is this? What's the leading term? It's a cube. So you'd go over here and click the widget, click the button to say, okay, I'm about to graph a cubic. Where I've solved mine all the way on my paper, just like we did in that example. It's going to cross, let's see, click the graph to plot the second point. So I plotted one of my x-intercepts. I have another x-intercept at -3. To plot the third point on your graph. And then I found an extra point at -1, -2. Let's see if it works. No, see, I don't... This widget, this is annoying. Maybe it's got to be right next to it. So I graphed 0, 0. Now I'm going to graph -1, -2. Now I'm going to graph the next 0, which was, I know, well, oh, found it. And then -4, 16. Okay. So here's how you do it in the MyMathLab. You're gonna on paper do the problem exactly like what we just did with that example. When you go to graph it in MyMathLab, they want you to graph, because it's cubic, they want you to graph 4 points, and they need to be in order. I don't know if you saw when I was trying it at first, I plotted both zeros, and then I tried to graph the one in the middle, and then it messed it up. So on my paper, I went from one of the x-intercepts to the next number I checked, to the next x-intercept, and to the next number I checked. So like this example right here, if I was graphing this in the widget, I would push the x cubed button to say, okay, I'm graphing an x cubed, and then I would plot that one, that one, that one, and then that one, and it should generate it.
Are all of the homework problems that have a graph?
No, there's only one graph problem. It's number 4.
Okay.
That's why I pulled it up. That's why I pulled it up, because I wanted y'all to see it. And you would hit save. Alright, let's go to... Do y'all want to see another graph? Another graph problem?
Sure. Oh. Is it funny?
Look at the next one. Graph this polynomial. the next one? I went too far. There it is. Grab this one. All right, what's the leading term? You should be able to. Leading term, don't write big, is 2x cubed. All right, what does that tell me, y'all? Saturday Night Fever, opening normal, right? So you got to think to yourself, left down, right up. And since it is cubed, I actually could just go ahead and put in the middle, you know, that it's just this nice little curve. Now we got to find the zeros. This is the part that most people struggle with because of the algebra behind it. Let's find the zeros, which means set the function equal to 0, and then decide how you're going to find the zeros. This is why we needed to do this example. This is not 2 terms, so you don't want to do the whole little single GCF to the front and then you're done. This is 4 terms, which means you need to do factor by grouping. You're going to group the first 2 terms together and the last 2 terms together. And then now it's exactly like the last problem, except you're doing it twice, right? So you ask yourself, what's the GCF here? What do they have in common? They got x squared in common. Pull it to the front. I'm going to move this over so I don't run out of room. Pull an x squared to the front of it, right parentheses, and now think of what would be left. If I factored an x squared out of that, I would have 2x plus 1 left. Now you're going to repeat with the second set of parentheses. And by the way, this sign here always goes with the GCF every time. So it would be -4 that they have in common. And then factor that to the front of it, and you'd be left with 2x plus 1. Now, part of this factor by grouping mess is that these should what? They should match. If they don't match, you did something wrong. Or if you did it right and they don't match, then it doesn't factor by grouping, and we don't have any of those. All of ours will factor by grouping. And if they don't, then I give it to you in factor form. Okay, so now what do they have in common? They've got the yellow in common. I need you to imagine pulling that, like picking it up and pulling it to the front as a single common factor. And then now you have to write what's left. If I pulled the yellow factors out, I'd be left with x squared minus 4, right? Yeah. Now you've got it to something times something equals 0. So you're ready to set each of them equal to 0 and solve. So here, subtract 1, divide by 2. Here, add 4. Now what? Square root. What's the square root of 4 when I'm solving? Nope. There it is. There's 2 totally different answers there. The next part is you take those answers and now you write them as points, because now you translate to yourself. Okay, so
can I please separate these kids?
she's on her way.
Thank you.
You translate them to points. So you tell yourself, okay, so these are my x-intercepts. I've got negative 1/2 0. I'm going to write that as a decimal. And what multiplicity did that come from? Well, if you look back up at it, it had a 1. So there's, with multiplicity, 1. And then I've got, what here? Just one of them. We've got negative 2, 0. Also multiplicity 1. And then you have positive 2, 0. Multiplicity 1. Now find the y-intercept. How do you find that? Remember, plug, have a good break, x equals 0 in to find the y-intercept. Go back to the original. Go to the original and plug 0 in. What do you end up with? -4. You end up with -4. So this is 0, -4. Put 0 in for x, but it's easier to plug it into the standard form because when you see it's just the constant at the end. The next part is to say to yourself, okay, I need a couple of extra points on here. I need some extra points. To get an idea of where you're picking your points from, I draw a number line. You don't have to draw the number line. That's just where I tell myself, okay, I need to know where I'm picking from. So I always plot my 3 x-intercepts. So we got what? -2, -1/2, and then +2. And then I go in between them and I find pretty numbers to plug in and get extra points from. Why did I not put the y-intercept on that? Yeah, because remember the number line's the x-axis. Don't plot your y-intercept number on here because that's on the y-axis, right? So you have the freedom of choice to pick whatever numbers you want. I personally, I picked, I picked -3. I picked -1. I picked +1, and I picked +3. Now, when you go to graph this in your homework, remember, it's just one graph problem in homework. You only need 4 points, and you've got 3 x-intercepts. So, really, just getting one more number in there should help you to plot it. Okay, so I'm going to plot my x-intercepts first. I got -2, -1/2, +2. Then I have a y-intercept at -4. And I know my end behavior is the left side's going down. I'm going to kind of remind myself, okay, the left's going down and the right's going up before I go to graph this. So how do I get the rest of it? Go to your calculator. You're going to type -3 in, see what you get, plot it. Type -1 in, see what you get, plot it. Type +1 in, see what you get, plot it. And then type 3 in, see what you get, and plot it. And that's where you get the rest of your curve. Okay? Check your calculator. Make sure you get the following. I'm kind of running out of room, so I'll put them over here. When I plugged -3 in, I got -25. So am I going to be able to graph that one? really shooting straight down, right? -3, -25 is way down here. Does that make sense? So I'm not going to be able to graph that one, but I can at least know that, okay, so this is definitely shooting down really far. Did I have any multiplicities other than 1? No, they're all 1, which means this is going to be just like a really natural flowing. You're not going to have to like come to it, lay across, cross over. You don't have to come to it, bounce back. You don't have to do that. It's going to be a natural flow. When you plug -1 in, did you get 3? So -1, 3. So it's coming up here. Now I can see that the curve, like when it's coming from down here, it's coming up there and then it's going to come back. And I've got to get the rest of the points. Is this making sense? When you plug 1 in, did you get 9? So right 1, up 9. And then the last one shoots off the grid. You plug 3 in, you get 35. So now we got to piece it together. What'd you get? Oh, it is -9. Thank you. It's negative. -9. Thank you. So 1, -9. There it is. All right, so the widget in MyMathLab, you would push that it's a cubic function. You would then just push a button on one point, then push a button on the next subsequent point, then the next one, then the next one, and it should sketch it. Okay, so now I've got to put all this together. I know the left side's going down, the right side's shooting up. Start to read it like a book. So you hit the right points at the right time. So I'm going to hit that one, then come to this one. There's the y-intercept. There's the next point, and then shoot up. All right, go to the next one and start it. Start the next one. When you first look at it, you're probably panicking. How many terms are here? 5. You can't factor 5 terms. So that's why if you look right after it, notice it's in factored form. We're not factoring 5 terms. We're not doing that, okay? So this is what's called the standard form, which is nice for when we're finding which intercept? The y. And then this is what's called factored form, which is really nice and helpful to see the exact zeros. So from the factored form, you can see exactly where it's crossing the x-axis. Because if you think about it, the zeros that would come out of it. Alright, so I'm going to repeat the same things that we did on the last one. So what is the lead term? The lead term, you can get that from the standard form. What is it? X to the fourth. Okay, so that tells me that it's an even degree, same in behavior, and it's positive, so it's both ends up, right? Now to find the zeros, it should be really easy because they also provided it to me in the factored form. I'm going to copy the factored form to right here. Okay, what zero comes out of the first factor? Negative one, right? You would set that equal to 0, and you get negative 1. What multiplicity? 1. What zero comes out of the second one? 2. With what multiplicity? What zero comes out of the third one? 4. What multiplicity? Don't you love this? It's the same steps over and over. And it's always pretty because of the rules of the polynomial. It's nice, pretty integers. Okay. So this hasn't happened yet, which is why we needed to do it. What does a even multiplicity mean it's going to do? It's going to bounce off the x-axis. An odd multiplicity means it's going to lay across it and cross over. We already had an example of that. Even multiplicity means it's going to come to it and then bounce off and go right back the way it came. All right, now let's write those as our x-intercepts. So that would be negative 1, 0 times 1. That one would be 2, 0 times 2, right? And this one would be 4, 0 times 1. Okay, how do I get the y-intercept? You plug 0 in for x to the standard form. It makes it a lot easier. What do you get? Negative 16. Now, an alternative approach without drawing the number line, I like to draw the number line. If you don't like to, I'm going to go ahead and draw it. I'm going to show you an alternative approach. Take your zeros and take a highlighter and tell yourself, okay, I got a 0 right here, I have a 0 here, then I have a 0 here, right? I just highlighted straight down. And then you could look at it and say to yourself, okay, well, I need to pick a number here. Then I would pick a number in between here. We already know 0 lands at where? The y-intercept's negative 16. Then you can pick a number here and then a number here. So that's an alternative approach to not drawing the number line, is going to the graph and just saying, okay, here's where they land. Where should I pick numbers? I'm going to repeat the number line just for, since I already started it. So I would pick negative 2. I would pick, you can't pick 0 because 0 is your y-intercept, so I would pick the number 1, and of course 3, and then 5. You're going to find that -2 and 5 shoot off the grid. You can't graph them. So really, you're only going to be able to graph the 1 and the 3 with the numbers you get from this. So I found that when I plugged 1 in, I got -6, and when I plugged 3 in, I got -4. I got -4. The highlight might also help you kind of see what point you have to hit next when you go to draw the curve. Which one had a new multiplicity? 2 had a multiplicity. So right here, you got to be careful. Make a note to yourself, like a, heads up, right here, if something happens, this is going to bounce off. Alright, so watch how I draw this. What did we say it's doing? In behavior-wise? Above, up. Okay, so from the far left, then it would be shooting up. So as I'm reading it, then I'm going to be coming down, right? Does that make sense? I'm going to come down. I'm going to hit that one. Now next would be the y-intercept. Was I able to graph the y-intercept? No, the y-intercept was 0, -16. So it's like way down here. I can't even graph it. So this particular graph is challenging to graph that. It would come up. Now here's where you got to be careful. This is the new part. It's going to bounce off of it. And that's because it had an even multiplicity. It's going to bounce off the x-axis right there instead of crossing over it like it did here and here. So that's the difference. Which with the widget, it'll take care of that for you. The questions in the homework, it's going to say straight up, what is the multiplicity? And you would type 2 in that case. Yes. I just wrote that there to remind me that, like, I'm going to need your textbook in the next 4 weeks. Well, if you've not used it, then you're welcome to go ahead and bring it in. You can turn it in, put a Post-it note off my desk on your textbook so that when I actually go through and mark, I'll remember that it was yours. How many it is? What, Becky? You did not disrupt. I got a text message about my kid. So that's what that pause was. It's me reading and I'm like, uh-oh. And that was, yeah.